To the Curious Calculator. In today's video, we're going to be going over probability. So we have some definitions listed out here, and let's begin by going through some of these, and then also I'll be giving some examples for each. So let's see here. The first one, we have probability experiment. A probability experiment is some specific action or process that produces unpredictable results. So an example would be something like rolling a dice. Oh, rolling a dice. Or another example would be flipping a coin. And so each of these are specific actions or processes that produce unpredictable results. In the case of rolling a dice, the rolling of the dice would be the action or process, and the unpredictable results would be like rolling a 1, a 2, a 3, a 4, or 5, or 6. And then in the case of flipping a coin, the action or process would be flipping the coin, and then the unpredictable results would be either getting a heads or a tails. And so let's see here. The next one we have outcome. An outcome is a result of a probability experiment. And I'll just say right now, for the remainder of the time, I'm going to be going ahead and following with the example of rolling a dice. And so an outcome for rolling a dice would be something like an example, rolling a 3. Another example would be something like rolling a 6. All right, so we have outcome. Now let's check out event. An event is a specific collection of one or more outcomes. So, for example, an event could be, well, I guess rolling a 3. That would be a collection of one outcome. And let's give another example. Let's say we have the event of rolling an even number. And so in this case, we would have the collection of 3 outcomes, which would be rolling a 2, a 4, or a 6, because all of those are even numbers. All right, so we got event. Now let's look at sample space. The sample space is all possible outcomes. So for the example of rolling a dice, we have that the sample space will be 1, 2, 3, 4, 5, and 6. So that is the list of all possible outcomes that we could have when we're rolling a dice. All right, so we did that. Let's look at the probability of an event. The probability of an event is how likely an event will occur. And this is typically given, or I guess not typically, but it is given as a number. So it's given as a number from 0 to 1. And with a 0 represents a 0% chance that event will occur. A 1 representing a 100% chance that the event will occur. And then something like 0.75 representing a 75% chance the event will occur. All right, so we got that. That's the general stuff here for probability. Now let's look into a specific probability known as theoretical probability. All right, so theoretical probability, as we can see here, we have some of the previous terms and definitions from above with the examples that I provided. And then we also have a new term and definition here, with the new term being favorable outcome. So a favorable outcome is an outcome that is included in a chosen event. So let's say that we choose the event of rolling an even number. Then a favorable outcome, let's see, we can give the example of, would be like rolling a 2. So that would be a favorable outcome because it is included in our chosen event of rolling an even number. Another example of a favorable outcome would be something like rolling a 6. Alright, so we have that, and now we're all ready to see how we calculate theoretical probability. So theoretical probability is found by, we do the number of favorable outcomes over the number of total outcomes, which is equal to the size of the sample space. So let's see a little example here. Let's say that we're rolling a dice and the event that we're going to choose is going to be rolling an even number. And if that is our chosen event, then the number of favorable outcomes we have is 3. So let's see here. Chosen event, I'll say chosen event even number. And then the number of favorable outcomes is 3 because we have either 2, 4, or 6, so there's 3 there. And then the number of possible outcomes is going to be 6 because that is the size of our sample space, which is the following 1, 2, 3, 4, 5, and 6. So we have 6 possible outcomes. And so if we calculate the theoretical probability of getting an even number when rolling a dice, we would get that that is equal to, so TP equals 3 over 6, which equals 1/2, which equals 0.5, which means that there's a 50% chance of rolling an even, or rolling and getting an even number. Okay, so that is the theoretical probability. Now, I want to move on and compare and contrast this with experimental probability. So let's keep in mind here that when we calculated the theoretical probability of getting an even number, we got that it came out to 0.5, which corresponds to a 50% chance. All right, so now let's look at experimental probability. So again, I've listed out some of the terms and definitions that I had prior, along with the given examples. And now let's notice we have some new ones here. So let's go through those. We have that a trial is the occurrence of a single probability experiment. And so let's see here. As an example of a trial, we could say, or I guess, yeah, let's just say it's rolling a dice, rolling a dice one time. And then a success is a trial that results in a favorable outcome. And so let's say that again, we chose the event to be rolling an even number. And so let's say we have a trial, and the success would be that if we, let's say, rolled a, in our case, a 2, or example, we roll a 6. Okay, so that would be some examples of a success if our chosen event was an even number. So now we're all ready to find how we calculate experimental probability. And experimental probability is the number of successes to the number of trials. All right, so let's see a little example of this. Let's see here. we have, let's say we're rolling a dice and we roll a dice 6 times. And out of those 6 times, we get an even number 2 times. And so that means that we have 2 successes and we did 6 trials. So I'll say number of successes equals 2, number of trials equals 6. And so our experimental probability, EP, equals 2 over 6 equals 1/3, which equals approximately 0.33, which would correspond to a 33% chance. Now, let's remember that whenever we calculated the theoretical probability of getting an even number, we got that it would be a 50% chance. But let's compare and contrast that with the experimental probability when we rolled a dice 6 times and we got an even number 2 of those times. And so when we calculate the experimental probability, we get that there's a 33% chance. So that tells us that the theoretical probability and the experimental probability may not always be the same. And that's going to wrap up today's video. I'd just like to end here with a fun fact from philosophy. Did you know that the ancient Greek philosopher Zeno was famous for his paradoxes? And one of those paradoxes is, well, it goes like this. It's like, say you're trying to get from point A to point B. And in order to get from point A to point B, you're going to have to travel half the distance. And then you're going to have to travel half the distance again, and half the distance of that, and half, and so on into infinity. Which apparently makes getting from point A to point B impossible. And this paradox was not solved until about 2,000 years later with the development of the mathematical limit, which is the foundation for calculus.